Okay, so these were finding the lateral area, and the lateral area formula is lateral area is equal to 1/2 the perimeter times the slant height. And we can sub in the perimeter, but we don't actually know the slant height yet. We need to calculate it, and this is how we're going to calculate it. We see there's a triangle in here that we can form that's a right triangle, and I'm going to sketch it out, and it looks like this. There is this height of the pyramid from the vertex, that highest point, down perpendicular to the base. So if we then drew a line straight out there to where the slant height would be, the slant height is this here in blue, we get a 90-degree angle. Okay, so then we've got, I'm going to redraw that down here. So let me do this. Oops. We have one side here, we've got another side here, and we've got this hypotenuse there that I've sketched in there, okay? And you can see that this is a right angle. Okay, so what do we know? We know that the height of this is 6 meters. And if you follow my laser pointer here down along the bottom, this whole edge is 12. So when you have this regular pyramid, if you dropped this height straight down, that would be exactly in the center, which means that if this whole thing is 12, then from here to the edge, the center to the edge is going to be 6. So we've also got 6 meters here. So this is, of course, a 45, 45, 90 right triangle, because there's the right angle there. And since these two are equal in measure, then we've got these base angles congruent as well. Okay, so it's 45, 45, 90, and then we know, based on that, without calculating, we can call this 6 root 2. You'll see how knowing your special triangles just actually starts to free up a lot of your brain power that you might otherwise be trying to calculate certain lengths. Just knowing that. You know it off the top of your head. So let's move this just off to the side here, and we will now plug in that slant height that we just found. So we found, let's see, we've got 1/2. The perimeter, if it's 12 to a side, then it's got a perimeter of 48. And the slant height we found is 6 square root of 2. Okay. It says to the nearest whole number. We're going to calculate this out first, and then we'll round it off. So 1/2 of 48 is 24, and we've got then 24 times 6 root 2. And when we multiply that on the calculator, we say, let's see, 24 times 6 is 144. Root 2, which you can skip one or two of these steps if you want to and just multiply that 144 times the square root of 2 and get 203.64, or approximately equal to 204 meters squared. And that's what you get for an answer. Let's do the rest. Okay, so what we need to do here is actually find the slant height again, and I'm just going to sketch this out. You can see that that's the height of 8, and this is the apothem length of 5 root 3. That would be cool that we had the apothem length, except we're not actually finding the area of the base. We're just finding the lateral area. So all that does is serve to help us find what the slant height is. Okay, so if we've got these two measurements like this, and let's say in blue we've got this slant height that we're trying to find, okay, then that will become that right there. And what do we know about those lengths? Well, we've got a length of 8 here, a length of 5 root 3 here. And because we are forming a right angle down here, we can then use the Pythagorean theorem to do this. We can say if a squared plus b squared equals c squared, then 8 squared plus 5 root 3 squared equals c squared. Okay, so 8 times 8 is 64, and 5 times 5 is 25. Root 3 times root 3 is 3, so 25 times 3, 75, equals c squared. And what do we get when we add these together? We get a 9 in the ones place, and 6 plus 7 is 13, so we get 139 equals c squared. That means that length is the square root of 139. Exactly. We could round it off now, but we're not going to, because we're going to multiply this all together, and anything that we round off too early will end up having some small change to it multiplied bigger, and we might actually be way off from what we want to be. So we've got the formula for this. The lateral area is 1/2 the perimeter times the slant height. So we say, okay, that's 1/2. What's the perimeter of this thing? Well, it's got a side length of 10. You can see here that side length of 10. And there are 1, 2, 3, 4, 5, 6 sides. So 10 times 6 is 60. We've got a perimeter of 60. And we've got a slant height we found of square root 139. Okay. So half of 60 is 30. So we've got 30 times the square root of 139 for our lateral area. And let's type square root of 139 times 30. We got 353.6, and that rounds to 354. What's the units? The units are centimeters squared, because it's area. And I box that. Answer. Okay, we're doing good. This one having also not the slant height, which we'll need to find. So let's draw this in. We've got this. Oops. We've got this actual height there, and we know, or we can calculate what that is. That length there, it's half of the full side of 4, so that length is 2. So if we drew that down here, and we said that height is 6, they gave it to us, 6 meters, and half of the full side of 4 is 2 meters, and then we're looking for the slant height, which runs down face down to there. And then we'll put that here and say, okay, then what can we find for that? Well, we would do the Pythagorean theorem again. So we can say a squared plus b squared equals c squared, or 6 squared plus 2 squared equals c squared. 36 plus 4, 40. So this is really c is equal to the square root of 40. We could simplify it, but it's not really necessary at this point, because we're just going to use that number that's going to be equal to our slant height, and that's all we need to worry about. And we will say the formula, lateral area, is equal to 1/2 the perimeter times the slant height is 1/2 perimeter of 4 plus 4 plus 4 plus 4, 16, times the slant height, which is square root of 40. Okay, or half of 16 is 8. 8 times root 40, And if we actually type this into the calculator, we could say square root of 40 times 8. And we get 50.59. That rounds up to, and I should have an approximately equal sign here, approximately equal to 51 meters squared because that's the units. Box that out. Yep, that's how you do them.